intro to the atom.
Everything is made out of something, right? Or maybe it's a combination of some things. But whether it's your lucky underwear, that car you really, really, really want, or your own toenails, everything in the universe is made out of certain pure materials.
Those materials are called elements. Some elements you've probably heard of, like gold, iron, and oxygen. Some might be new to you, like thallium, hassium, and ruthenium. Elements can be solids, liquids, or gases, and they can exist in nature or be made in the lab.
An element is a substance, like hydrogen, oxygen, carbon, silver, or boron. Say you had a piece of silver and a really special knife, and you chop that piece of silver in half. Then you chop it in half again, and again, and again. You keep on chopping that silver in half until it's super tiny. Eventually, you'll reach a point where the piece of silver is as small as it can be and still be considered silver. At this point, you've reached the silver atom.
This is true of silver and all the other dozens of elements. For instance, the very smallest piece of chopped up boron that can still be considered boron is the boron atom. You get the picture.
So everything's made up of these teeny tiny atoms, even you.
Preposterous! I am made of snakes and snails and puppy dog tails. Or so Mummy told me.
Atoms are so small that nobody can actually see what they look like, even with a powerful microscope.
Wait a second. I've seen pictures of atoms. If we can't see them, how do we know what they look like?
We'll get there in a minute. But first, let's talk about...
Not those kind of models.
Scientific models help us think about things that are too big, too small, or too complex to work with at their actual size. Have you ever seen a mobile of the solar system? That's a model of something that's way too big to be seen from one place. The globe is a model of the Earth, and sometimes movie productions use models if they want to destroy something too expensive or important to destroy at full size.
It took a long time for humans to figure out what the world is made of. But in 1913, a Danish scientist named Niels Bohr got pretty close. He made up the model of the atom that we use today.
People knew about the elements before Bohr came along, but they hadn't really found a model of the atom that stuck. Some scientists thought atoms were either hard spheres like billiard balls, or little balls of goo with electrons scattered in them like chocolate chips in a scoop of cookie dough. But Bohr changed everything.
According to Bohr's model, the atom is a little cloud of energy with a solid center. That center is called the nucleus. The nucleus is a dense little ball of particles called protons and neutrons.
Moving around the nucleus at super high speeds are even tinier particles called electrons. They make up the cloud part of the atom here.
Electrons are so fast and so small that it's actually impossible for us to know the path of a single electron over time. We'll talk more about that later, but that's why we use Bohr's model. It's a simplified version of what's really going on, but it's still helpful.
Now that we're clear on models, let's get back to the atom itself.
Some of the parts that make up the atom are electric. A tiny bit of electricity is called a charge. Charges come in two kinds, negative and positive. Two objects of the same charge always push each other away, while two objects of opposite charges pull each other together.
All protons have an electrical charge of +1, and neutrons have no charge at all. That means the nucleus has a positive charge. All electrons have an electrical charge of -1.
Hey! I thought the nucleus was made of positive protons and neutral neutrons. If the protons repel each other and the neutrons don't keep them together, why doesn't the nucleus just fly apart?
Well, you won't need to know about this until later, but there's a force that's stronger than electrical charges. You'll never guess what it's called. The strong force.
Real creative naming, guys.
It keeps the nucleus together.
Anyway, most atoms in their natural state are neutral in charge. The number of electrons is the same as the number of protons. So the positive charge of the nucleus is canceled out by the negative charge of the electron cloud. The whole atom has no charge.
For example, a lithium atom has 3 protons. This means most lithium atoms also have 3 electrons moving around the nucleus. How do we know? Well, the atom's neutral in charge, so the charges have to cancel out.
Now wait a minute. I thought you said an atom is the smallest piece of an element. How can the smallest piece of something be made up of something smaller?
Well, the protons, neutrons, and electrons that make up the atom are more like building blocks, and they combine in different ways to make atoms.
Let's go back to the old cookie model. Cookies.
Say you're making cookies. You're probably going to use flour, sugar, and butter. Those ingredients are in pretty much all cookies, but they aren't cookies until they're mixed together and baked. It's the same with atoms. Protons, neutrons, and electrons don't become atoms until they're combined.
I feel better.
Great!